start whenever you're ready.
Okay. I will present you a framework for mathematical application generation. As you will see, the philosophy is very different from the previous talk. It's interesting to see that this community we have a different approach for the same problem. The evolution of the web application started from static documents, only pieces of text with some pages and some hypertext links, to simple application like search engine and e-commerce. Now we are going to see general application. What I call general application is in fact all the businesses and usual application you find in corporation and so on, that will arrive in the web form. The tools for this application evolve probably the same way that the applications. But for the first generation of application, you have to use HTML or THTML with what you see, what you get, editors like Template, Dreamweaver, or things like that, or powerful general purpose editors like Emacs. And the first application we are done with the CGI interface and scripting languages like Perl. The second generation application has been done with the server-side script languages like ASP, PHP, Perl, Python, etc. On those generations, the script language is included into the web server. So you don't have the performance problem when you spawn application like the CGI application. But these are still script languages. And the script is generally mixed with the HTML in the pages. The current generation application tools are .NET for Microsoft and G2E for a lot of people, like IBM, Sun, and other people. These are now. This is not scripting languages anymore. You have full-fledged languages like Java or C#, J# on .NET. But for me, they are still used as scripting languages. All the people I've seen who use these tools, generally they look for libraries on the net or pre-made libraries, and they assemble application by calling these libraries. So for me, they are still used as scripting languages. So the next generation application tools, why not Kubernetes? Because as we have seen, the complexity of application is rising, and Kubernetes has all the qualities to generate those applications in a much more powerful way than the alternatives. As the application domain of web application is very, very huge, we have to restrict the current domain in order to be able to make a framework that is usable. So the first point is corporate acceptability, because we want to use this to make software for corporations, and so it has to be acceptable for these people. Data-centric, we will focus on application that uses a lot of data classes, tens, hundreds, or thousands of kind of classes. It will be very different, for example, from a system like a search engine, where you have a very simple interface. Here we want to focus on application that will have a lot of objects. And a partitionable concurrency model, we are looking for an application where a small set of people work on a small set of objects at the same time. For instance, if we do some kind of accounting or payroll application, we can have tens of thousands of people using this application, but for each company, only a few people will use the object of this company. These are the choices we have made to restrict the problem. In addition to these engineering constraints, we have added some engineering constraints, like data integrity. We want the list frameworks to deal with data integrity. We don't want to leave this to the database. No. The UMI view generation, as we want to focus on application which will have a lot of classes, we want the views to be automatically generated, because otherwise it will take too long. In view coherence, we want that if people look at the same object, they see the same thing. We don't want to have a view on the computer that is not coherent with another view on another computer. This will allow collaborative work as well. Application navigation should be automatically generated also. Flexibility, we want to be able to change the classes, the slot of the classes, add things to object classes or remove them, etc. Portability, we want this to work on the various operating systems like Linux, Unix, Microsoft Windows. And performance and scalability, because we want this to be really usable. So it has to have enough performance, and it has to be scalable to be used on a larger scale. So why command? First, we have command gives performance, but we can't find with the other systems, because it is a language that is compiled. And also, as we will see, we can use the macro and the dynamic code generation to compile code that will be used on the application on the fly. So this will boost performance as well. Stability. Permanent is an NSI standard. It doesn't change every day or every 6 months. It is here to stay also. An excellent macro system. We make a lot of use of macros to generate a lot of things like the HTML or the predicates for the data integrity and other things. The most powerful object system, we rely a lot on the data object protocol to make the object presentation and to do all the introspection stuff with the object, and also to be able to save the memory object to databases. Lexical closure are used mainly to deal with the interface. As the HTTP protocol is stateless, we have to maintain a state on the system, and for this, lexical closure are a big plus. Dynamic code generation and compilation is used mainly for generating HTML, generating interfaces, generating the code on the server side that will deal with the interface, and also to compile rules and predicates for the data integrity. Debugging and dynamic modification of running systems. This alone is a big time saver when we work on real systems, because when there is a problem, this point the debugger, we can look at it, modify it while the system is running. And resilience to the changes, because when you work on the system, the client always wants to make modification of that, and you have to have a system that is very resilient to changes. Otherwise, you spend a lot of time rewriting a lot of things. The general architecture is a classical one for the current generation of application. We have an HTTP front end, which is for now Apache with Modlist. Modlist is a connector to transfer the Apache request, HTTP request to the Lisp servers, which we have chosen this for several reasons. First, because for the corporate acceptance, it's always easy to tell corporations that we are using a de facto standard like Apache rather than another Lisp server. But there are also other reasons. We don't want to waste Lisp processing power to deal with HTTP protocol and to deal with serving static content like images or static text. So for this, Apache is a good choice. There is also security consideration. The application server will not deal with, will not be on the internet. They will be on the local area network connected to the HTTP frontend. The application servers are the Lisp processes. They perform all the logic of the application. These are made with the framework, and they are the core of the application. They process the HTTP requests that are transferred from the Apache frontend and pick the data in the database. The database are either S-expression database, which is a very simple one, which is very flexible and very easy to use. It has two disadvantages: it does not scale, and it is not acceptable for corporations. So we added an SQL database layer, so we can tell people that in fact we are completely standard. We have the data in the SQL database, the front end is Apache, and so we can minimize the Lisp part, because as we all know, this is very difficult for when we have a client to tell them that we do this in Lisp. The core of the application is based on the class and the object descriptions. For this, we added slots to the meta class. So here are some of the slots we've added. A unique identifier, which is used to be sure that the class is unique among the other class of other systems. Instantiable is the boolean to tell that this class can be instantiated by the user. Username is the name to present to the user for this object. All the user text is multilingual. For now on, we have English, French, German, Spanish, Italian. The SQL name is the name of the SQL database if it's not the same as the class name. Description is just the descriptions used for documentation. Version is the version of the class. It's mostly used in the S-expression database because we convert the object in a Lisp manner. When we read them, we look at the version of the object and we translate it in the version that's needed. Direct views are the views defined for this class. The automatically generated views are not put in direct views, they are automatic. Direct views is for the semi-automatic or manual views. Direct functions are the functions that can be used by the user on this object. The rules are the integrity rules for the object. We have two levels of data integrity. The rules that work on the object as a whole, and a value constraint predicate that works only on the value on the slot, on the per slot basis. In addition to the meta class slots, we have added some slots with slots definitions. So again, a username, which is bilingual, an SQL name, a description. Value type is the type of the slot, and it's not the list type. It can be, we define some types for use with the interface in the database that are disjoint from the list type. For instance, in list we have a universal type, which is an integer, but in the database we will say that it's a time of day or a date or timestamp or things like this. List of values, the boolean to tell that this slot will receive not only one value but a list of values. Unique, the value must be unique. Stored, the value has to be stored in the persistent database. Indexed, the value will be indexed. Null allowed is to allow the possibility to have a nil value. Unit is the unit of the slot, like millimeters, inches. The read-only groups and hidden groups are for the access control. When you can define a group of people, and if this first slot is read-only for this group, the user will see it, but can't change it. If it's hidden, you will not see it as well. Disable predicate, it's to disable the slots based on a predicate. So in the interface, the slot will be disabled. Void link text is the text you put when you have a link to another object and that object is not present. It's also a keyable item. View type is to precise the type of view we want for this slot. In the automatically generated views, we look at view type. If there is a type of view which is preferred, we use it, or otherwise we use the default type. Session and state management. For this, we use, as we all know, HTTP is a stateless protocol, so we have to keep some kind of state. For this, we have chosen to use encoded property list, so we can put almost everything we want into an URI. I think the best I can do is to show you how we do stuff. We try it. Okay, here is how it looks. I'll copy it. Okay, so here you can see the URI which was used in the browser, and when I decode it, I get back a property list with the different parameters I put in it. Linked with the properties, we have a session identifier, which can be SSL session ID if it's an SSL session, or robot session ID if you identify something like a Google bot or a Tabista bot or things like this. When the user connects to the system, we look at the session ID. If there is a corresponding session object, we will use it. Otherwise, we will create a new session object. We will re-encode the URI with the current item of the property list by just changing the session ID value, and redirect the system to this. For the UI management, the user interface management, we decided that the classical use of HTML, HTTP, in general, you are in pull mode. That is, you fill in a form, and when you are finished, you submit, and then you eventually get some errors, so you get back to the pages with some text saying this is wrong, you missed this field, etc. So we thought it was not practical to use for real applications. We decided to use a mix of pull mode and push mode. For instance, I will show you. Here, this is the beta application. If I change a value here, you see there's no submit button or things like this. When I change for instance, the name of the class, switching the English name, class 1, for instance, when I leave the slot, when I leave the edit control, the server is notified of the change. So we can correct it, verify it, and correct it if needed. There is no submit button. And the use of the push mode also enables us to do the view coherence and the collaborative work. So here, if I open a second window, we have two windows of the So I will switch back to English. If now I switch back to class 1, the other window is notified that the value has changed. For generating the HTML, we use the LHTML representation. I think it was John Fodéraro from France which published it first. In this representation, we treat HTML as an ASCII expression with keywords denoting the values of the tag. The major interest of this kind of representation is that we can, as it is as expression, we can work on it like any list code. So we can have macro tags, we can generate it automatically and manipulate it in list in a fairly easy manner. For those who are not used to this, I have an example here. Here is an LHTML representation of a table. The HTML tags are represented by keywords. And if instead of the keyword, you can put a list with the keywords as a first value and the attributes as the rest of the list. This representation can give very good performance because we can compile it to optimize this code. So here we see that this LHTML representation is converted into a red string which takes all the code which is constant. Then it prints the variable to the HTML stream, and then it has collected all the constant text after this value. The major interest of this representation is that we can do fairly complex macro stuff. For instance, here a second example where I have a JavaScript tag. Here you can see it, JavaScript, which will be exported to a classical HTML tag like a script, language. Was a JavaScript tag, etc. So this representation can be used to define a lot of specific tags, and those tags can be exported later depending on the browser. If it's Internet Explorer or Netscape, you can generate different code without needing to bother when you write the function. The views, as we have seen, the views use remote scripting to get the set values. They are automatically generated or semi-automatically generated. When they are automatically generated, we take the information for the type of the slots, the different options we have for these slots, and then we generate a simple view of the objects. When we want to semi-automatically generated views, we have defined some tags in HTML. So here is an example of the object view. This tag is a tab layout pane. So I would say I have this for a translated string. So I can show you what it looks like. This is the view that is embedded here, with the French, English, German, and so on. So here I define a tab view, and I put the values, the name of the tab, and then the view I want. Here we see there is a tag which is slot edit, to mean that I want to edit the French slot of the object. And these are exported to the correct HTML to process the interface of the slot. As these are views, HTML is pure Lisp S expression, we can use the backwards macro to automatically generate some complicated ones. So here is the object view for the object, for the class object, which is this one. We have a description pane, attribute, views, function, rules, etc. This is generated by this view. So here we see again the tab tag, and then the different panes. So for instance, for description, I said I want a standard slot views for the class slot info with the view with the slots name, username, SQL name, description, etc. As we were looking to do business application, every business application you have to generate documents. So for this we use CLPDF, which is a library we've written to automatically to generate PDF format files from command list. And take when we want to do a more complex document or a mix of the both, because we can use we can generate some parts with CLPDF and then include them in the tech document. The meta application is the first application written with the framework, which obviously was the framework application itself. This is the application I've shown you later. So this application, this is just an interface over the list classes. Here is the view of a class. So you have the slot we've already seen, like internal name for the user, the description, progress status, the comment, the class identifier, and so on. The attributes are the slots. If we look for instance, the class 2 list slot, this is a view for a slot with some general information, then some information about the value. So here we see the value type is another object. The object type is class 2. I can change it. Here we have see this object is a list of values. The new object are inserted first. There is the no unit. You can create a new object. If we go back to the class, we can ask to see the list source for this class. So this can be directly cut and paste in other programs. We can look at the graph of the classes. Well, here for the demo, I have only 2 classes, so it's not very interesting. I will show you the graph of the classes for the meta application. This is very handy, especially to navigate when there are a lot of classes, because we can click on them to go to the class. If here I look again at the class, for instance, I want to look at class 2, I'll go back to class 2. So this is very useful. And then I can test the class, which has been defined. So here the dev class is collected from the information, it is evaluated, and then an automatic view is created and presented for the object. So I can put the name, boolean. We have some server-based widgets like calendar. We can add objects to the list. And this is automatically generated. Here, I don't have a database, so this won't be saved to the database, but the system is fully functional. You just have to add the business logic you want, because obviously this won't do the business logic for you. We have added some support for web services, basic XML RPC support, because this one is very easy to use and to support. And we will probably add a SOAP in the future if it is needed. But SOAP is a rather bloated standard, so if we can avoid it, we avoid it. The XML RPC, we have used it already with some clients. Rather happy with it. The current state of this framework is still in alpha state, but it's already promising. We use it on some application. First, the meta application, which is my test application, and then we are using it on the. We have done for a bank communication networks, statistic and map generation software. We fetch in an SQL database the link they pay for the communication, such as fiber optic channels and broadband channels and so on. And then we compute some statistics and we draw maps of the world with the links on the maps, so they can see that they are paying sometimes for things where they don't have any subsidiaries anymore. We also make traceability software for the food industry. Yeah, it's a traceability software for the temperature. When you send some meat, for instance, from one place to another, you have to ensure that the temperature has been low enough. And so for this, we put some electronic board in it, and then we use the internet application to read back the electronic tag when the food has arrived. And we are also doing a benefits management software, also for the financial industries. So, as a conclusion, I would say that from the first test we have done, it was rather well, and it's much faster than using .NET or things like this, especially when we want to modify the modification cycle is very fast. And the chance of common list has been corrupted by the result because we couldn't have done this in Java or things like this because it would be too much line of code. The JBoss, the open source application framework in Java, is something like 0.5 million lines of code. And this framework is only 16,000 lines of code. That's it.
Those URLs you're using, are they marshaled data? Have you got the entire state marshaled into those strings? Sorry? Those URLs, say the one you can see in the browser there, yes. Is that the entire state, not all is there?
No. It's only part of the state, because of this we have the object identifier, the state of the object, we have the session identifier, things like this, so we can put what we want, but not all. Would be slow?
Yeah, okay, so you're at the database side. That's where the user has got to and all their current choices already. That's all marshaled in the database. Sorry?
The microphone, please.
The user is jumping up and down some sort of browser stack. And where they've got to is all marshaled into that encoded.
Yes.
Set of characters.
Yes. The only say this, they can't say that they don't know where they are from the URL.
When you showed the demonstration of changing the name to the user, /1/ONE,
Yes.
Did you do a round trip to the server, or are you maintaining an open connection and using JavaScript to communicate back and forth to the server?
No, there is a communication link between the server and the views. So when you change one view, the change is propagated in the other view. Yeah, let's switch to English in both. So when I leave the edit control, there is notification to the server. The server uses the predicates and the rules to verify that the value is correct, and then it changes it in the object. And there are a lot of clauses that maintain state, and so this will be propagated back to all the views on the object.
How are you maintaining that connection?
We tried almost everything possible. So we tried ActiveX, applets, hidden frames, the new .NET behaviors. We tried everything. There's no solution that works in every case. So you have to use, for instance, one for Internet Explorer and another one for Netscape. Here, in this demonstration, we used hidden frames.
Sorry, is this what you're using?
Hidden frames.
Hidden frames.
Yeah. And then we change the reference of the frame, so it will fetch back on the server and get the value.
What is this product called? What is it called? Your product, what is it called?
No name.
Is it available?
No, we used it internally, but for now, we are only a very small company, but two.
You mentioned the database with the S expressions, meaning memory resident S expressions, and then at some point, when they got too large, you would encode them out into an SQL database. At what point, how many expressions would you expect to hold in for? What size, and how well does the SQL database scale up in terms of finding and reconstructing data?
Yeah, the SQL database is mainly for the corporate acceptance problem, because if you tell to a corporation that you are using S expression as instead of data, they will say it's not good. So we could transform the S expression into XML, so this will be acceptable for people, but it's of no use. So now for the clients, we generally put directly the SQL one.
How about the scalability of SQL?
The scalability of SQL?
Of your application there, you have a problem access. Do you read back from the SQL database?
No, the objects are read from the SQL database, and then they are normal serious objects, and we manipulate them, and they are saved to the database at some time, but with the memory, we don't fetch them each time.
I'm just curious about the problems of scaling up in the number of objects.
We reviewed this with a fairly large number of objects, but not very good so large, some kind like tens of thousands of objects. It was very well. But this is why we were chosen a partitionable concurrency model, because we can't put millions of objects or millions of applications in one list process. So with the load balancing, will redirect users to one list process, while it will deal only with the object used by few people, like tens or hundreds, but not millions. The time is over, but if you want to ask questions to me, I will be available here for the rest of the conference. Thank you.